Okay, example 1, graph x is less than 3, domain is z plus. Now, first of all, if you recall back from Algebra 1, we dealt with the sets of real numbers. There was the real numbers, then the rational and irrational. And the rational broke down to integers, whole numbers, natural numbers, and those all had letters to denote them. Z was a set of integers. If you recall, integers would be all the numbers that are not fractions. That includes negative numbers, positive numbers, and 0. When you see a z plus, that's representing just positive integers. So 1, 2, 3, 4, 5, and so on. So they're telling us to graph this inequality, but they're putting a filter, a domain, saying that we only care about numbers that are positive integers. So looking at this number line here, each number denoted here, 1, 2, 3, 4, 5, 6, those are all positive integers, right? The next number below 1 will be 0, which is not a positive integer, it's 0. 0 is not positive or negative. Okay, so if you imagine all the numbers less than 3, that would be an open circle at 3, and we'd shade to the left, go forever. All right? If we put a domain on, though, specifically integers, we don't have open circles when we graph integers. The purpose of an open circle is to say get really, really close to this without including it. So if I put this open circle, don't do this on your paper, and I were to shade like so, I'm including 2.9, 2.99, 2.99. I can't actually graph those numbers, so the open circle is denoting that I'm getting as close to 3 as I possibly can without touching 3. That's the purpose of the open circle. When you're graphing integers, there is no open or closed circle, or open circle at the boundary. There's just the first number that makes it true. The first positive integer that is less than 3 is 2.
And the hole has to be closed?
It needs to be closed in, yes. Because 2 is less than 3, the purpose of the hole is to say I'm not including this number, but I want to get close to it. I do want to include 2, so I'm going to put a filled-in circle there on 2. The next positive integer that makes it true is 1, and that's it. Right? There's nothing else. The next integer down from there is 0, but that's not positive. So one of two things is going to happen when you get a domain. It's either going to be an infinite set or a finite set. Finite meaning there's only a specific number of points that need to be graphed. When you get a finite set, we don't fill in these arrows. We just graph what's true. All right? If we get a small finite set like this, great. If a set had 1,000 numbers and it's still finite, I don't want to graph 1,000 numbers. So if, let's say, x is less than 3,000, and we got the set of positive integers. Let's say we had to graph that thing. Okay? There's only 2,999 numbers, less than 3,000, that are positive integers. Finite means you can count up to that number. We could. I mean, if we had a day to sit around and do nothing but count, we could count up to 3,000, right? Or 2,999. So the way you would graph a finite set that has a huge amount of numbers in it, I'm going to put 0, and then 1, and then I'm going to put 2,998, 2,999, and 3,000. I'm going to put a break in the graph here, and I'm going to graph 1, and 2,998, and 2,999. And this implies that everything in between here is going to be graphed also, because the one before and the one after it's graphed. So I just graphed 2,999 numbers without getting writer's cramp. Okay, so if you got a whole bunch of numbers, that's how you handle it. They stick to pretty small numbers in the book here. If it just says x is less than 3,000, and the domain's a set of integers, not z plus, but just z. Now it goes all the way down to negative infinity. Now it's infinite. Now it can't be counted. All you have to do to graph that make sure that 2,999, so 3,000 is there, right? 2,999 be the first thing graphed, and 2,998, 2,997, and then we make that arrow bold to show that it goes on forever in that direction. Infinite sets, just the bolding in the arrow is sufficient to show that it goes on forever. But again, with the finite sets, that ones that have a beginning and an end, you need to make sure the beginning and end both show up on your graph when you graph it.